Hey guys, my name is Trevor Sullivan, and welcome back to the StratusGrid YouTube channel. In this video, we're going to actually build off of a topic that we were talking about in a previous video on our YouTube channel, which covers DynamoDB transactions. And in that video, we talked about transactions and we took a look at the Rust code to actually create a GET transaction and some of the intricacies of building out GET transactions. But we kind of ran out of time in that video. I didn't want to make it super long, and we ran out of time to actually talk about write transactions, which are quite a bit more complex than GET transactions just due to the nature of different types of update operations or mutations, I should say, that you can apply to Amazon DynamoDB items with transactions. Now, just to really quickly review some of the key benefits of transactions, first of all, you can have up to 100 individual items or actions inside of a transaction. And each item that you target can only be targeted once by a specific action. So each of those actions has to target a unique item in a DynamoDB table. Also, transactions can span multiple tables as long as they belong to the same AWS account and region. And you can also have a payload of up to 4 megabytes for the entire transaction. So keep in mind that DynamoDB items individually have a maximum size of about 400 kilobytes, but the entire payload of a transaction only is capped at 4 megabytes. So if you're writing, let's say, 100 new items with a write transaction, and each of those is 400 kilobytes, I think if I'm doing my math correctly, that would be about 40 megabytes of data. And so you wouldn't be able to write full-size items 100 times with a single transaction. So just be thinking about the payload sizes as you are dealing with these transaction APIs. So basically, I've got a earlier video on here. It'll be published in a couple of days here on Get Transactions. So make sure you go out to the StratusGrid YouTube channel, hit the subscribe button so you can stay up to date with the channel and check out any new videos. Also, if you go to the Home tab right here, we have some featured playlists here, such as Rust development and AWS that'll help you to really focus in on high performance programming in the AWS platform with Rust. All right, so just to review really quickly, our project right over here in Microsoft Visual Studio Code currently has a function here called test get DDB transaction, and we wrote this code in order to create a couple of individual get actions, and then we wrapped those inside of a transact get items call here. But now we're going to shift gears and actually talk about doing mutations or write transactions. So we're not going to be using transact get items. We're actually going to be using transact write items instead. So let me start by showing you the underlying REST API for that. If we head over to the Amazon DynamoDB documentation and go to the API reference, not the developer guide, but the API reference for the REST API, we should have a transact write items API here that we can drill into. And if we check out the request syntax and take a look at the data structure here, we have a lot of similarities with the data structure of the GET transaction, but we actually have 4 different types of actions that we can perform as part of a write operation. So first of all, we have something called a condition check. This is kind of a unique capability. It's not actually a write action. You're not actually writing or modifying or deleting any data out of a table. What the condition check is it allows you to add a condition so that if that condition returns a falsy value, then the entire transaction is going to fail and be rolled back. None of the actions in the transaction will actually get committed if the condition checks in the transaction do not return a truthy value. So that's kind of a nice option to have if you need to basically do a lookup against a particular item and do some value comparisons on it. You can use the condition check for that purpose. But the main things that we have here as far as actions go are the delete action. So if we want to delete a specific item from a table, if we want to put an item, so this is kind of like creating a new item, and it'll also update an item if it already exists. And then down here, we have an update operation. So if we want to identify a specific item that we know already exists and we want to update some of the attributes on that item, we can call the update operation here. So we also have for each of these actions, because each action can target an item in a different table, as long as they're in the same account and region, each of those actions is going to have its own table name property that we have to specify here. Also, the update operation is a little bit unique. It has this update expression here that allows you to basically express what the new values are going to be for the item attributes after the item is written. So if you want to do some really basic mathematical functions or something inside of this update expression, you can go ahead and do that. If we head over to the developer guide here, just do a search for update expression. I think that they have a guide on how to do that right here. So sure enough, right here, we have update expressions here. We can, add things to sets if we have a string set, kind of like an array, or if we want to remove an item from a set, we can do that as well. So this just kind of gives you a basic syntax to modify attributes on a particular item. All right, so what we're going to do is actually go ahead and call this API here, and we're going to start by just writing a new item into the table, and then we'll take a look at how the condition check actually works. So you can always reference the REST API documentation. Even though we're writing Rust code, the REST API documentation is really the underlying API that's being called by the DynamoDB crate for Rust. That's just a wrapper around this REST API. So technically, this is the authoritative documentation for the underlying API, but the request attribute names that we pass in here, these property names, are going to be a little bit different just because they're put into a Rust-friendly syntax with underscores as separators and all lowercase characters, rather than having this, I think that's called camel case, perhaps, where you have capital letters here for each word. So just keep that in mind. Transact items is going to be a property, but it'll be lowercase and it'll have an underscore separating transact items in Rust. Same thing for the actual function call here as well. So you can just kind of refer to get transaction here as an example of how we add these individual actions. The difference here, though, is that previously with the get actions, we had this get data structure that we would wrap in a transact get item. So now instead of a transact get item that we add to the transact write item API call, we're going to have a transact write item data structure that's a little bit different. And then we're going to have separate data structures. Rather than calling them get, there's going to be a put, delete, a update, and a condition check data structure that we can use in the SDK. And then we can wrap those in a transact write item data structure, and then ultimately add those transact write item data structures into the transact write items API call, again using the transact items function here, which maps to this property in the JSON payload for the request. All right, so let's go ahead and build out a new function in our code here. I'm just going to comment out this call to test get DDB transaction here, and we'll add in another function called async function test write DDB transaction. And I'll just put on the end there, and we can create other functions for other actions if we have time to explore those. So for starters here, I'm just going to copy this input argument, which basically just takes a reference to a DynamoDB client data structure. And we've already constructed that up here in the main function. So what we're going to do is just pass a borrowed reference into the function here, so that we can continue to use this DynamoDB client rather than having to instantiate it every single time in each of these test functions down here. And then in my main function here, we'll call the test write put function here and do .await, and we'll go ahead and just do that. And now inside of here, we can go ahead and start writing our code. So let's start by actually writing the code that calls the API, very similar to what we did right down here. We actually called the transact get items API and then do send.await. Send creates our future, and then await is the Rust keyword that actually causes the future to be invoked. So what we're going to do is change that to DDB client, which is my function argument right up here that has the client data structure. And then we'll do dot, and then we'll search for write, and I'm going to choose transact write items here. And we'll assign the result to, let's say, put result. And then we can start to build out the function arguments here. So we're going to do .send, .await, and then in here, we're going to add in our items. So if we search for items, sure enough, we have this transact items function, just like with the get operations, that allows us to add in actions into our array of transact items here. So transact items can have up to 100 individual items, and each of those items, like this entire thing right here, actually represents one item that does a condition check. And then everything from here down to here represents the structure of a delete operation, and so on and so forth for put and update operations as well. So we're just going to construct these individual actions and then wrap them in a transact write item data structure, and then add that to the API call under the transact items property here. So what we need to do is find the transact items data structure. So let's go over to the crate documentation. If you go over to the website docs.rs, docs.rs, and then search for the DynamoDB crate, this is the authoritative documentation for the actual Rust crate. So if we search for transact write items, sure enough, we have this data structure right here. That is, this is actually the operation. So you can see it's under this operation module. But what we want to look for is I think actually transact write item, and that's under the types module here. So it doesn't have an S on the end of it, but this is the wrapper that we have where we either apply a put, delete, update, or condition check operation. So this is what we're going to construct. We'll do DDB types. So if we check out the crate here, again, we have a use statement up here that says use the crate as DDB for short. So that's just an alias. So anytime we type DDB here, that is actually referring to the DynamoDB crate. Then we have the types submodule right here directly under the root of the crate. And then we have the transact write item struct that belongs to that types module. So that's the structure of this reference to that data structure. And then we're going to use this builder pattern, and this is really common across the AWS SDK. And actually, it's kind of a good practice in general. You have this builder pattern where you have a data structure that provides helper functions to actually build out a different data structure. So if we call this builder function on the transact write item here, that is actually going to give us, if we go to methods here and then take a look at builder, you can see that returns a transact write item builder data structure. And if we drill into that builder data structure, then we can see that we have methods here to append an update operation, a put operation, a delete, and a condition check operation. And then for each of those, we can drill into the update data structure here, for example. Same thing for the delete and the put and the condition check. And then this is the complex data structure that we have to construct in order to put a new item into a DynamoDB table. So let's start by creating a builder here, and I'll just go ahead and create a variable here called put01. And then once we create the builder, on a new line here, we'll go ahead and call the put operation because we're going to be just writing a new item into a table. And then this put function here is going to take a put data structure. So on the builder, if we go to the put function, we have to create a put data structure that has all of these properties that, again, correspond back to the REST API. So if we look for transact items and then go down to put, you're going to see we have condition expression, expression attribute names, expression attribute values, and then item here. Item is really going to represent the individual attributes that we are appending to the item before we actually write it to the table. So basically that data structure is going to allow us to specify all of those parameters. So I'm going to call this variable put01. Let's actually do put01 transact. And then up here, I'm going to say let put01 action equal a new DDB types. And then we'll look for the put data structure here. And then once again, we're going to call the builder function on it so that we can get a put builder. And then we are going to specify things like the table name, right? So back over here in the documentation for the put builder, let's go to put builder data structure. And on the put builder, we have methods like table name that allow us to set the name of the table as a data type that implements into string. So basically any item, any data structure in Rust that can be interpreted as a heap allocated string can be passed in to the table name. So I'm just going to go ahead and use a static string for now. And I'll do the table called Trevor Products right here. And just to refresh your memory, if you didn't watch the earlier video, I'm going to open up the AWS console here, go over to DynamoDB, and then show you the table that we're going to be writing a new item into. So let's be in the Northern California region, go to DynamoDB, and then I should have a table in here that's called Trevor-products. And then just to refresh your memory, the partition key is going to be the P_category, it's short for product category. The sort key is going to be P_name, short for product name. And any other attributes are totally optional, right? But the partition key and sort key are mandatory because they're specified as the table schema. And if we go to explore table items here, we do have several items here. You can see one of my items is actually missing is available and price. That's totally valid though, because is available and price are not part of the table schema. They are optional attributes, but coincidentally, I just happen to have that as a standard attribute on most of my items here. So what we're going to do is we have to make sure that we specify P category and P name at a bare minimum, and then we can add in these other attributes if we want to. So what we'll do is go into .item here. And what this is going to do is it's going to add a key value pair as an attribute to this new put action here. So if we do .item and then specify P category as the attribute name, and then use the attribute value data structure here, which is again under the DDB types module here. And we want to use the S data type, which in DynamoDB is the string data type. And then we need to create a heap allocated string that we pass or kind of wrap inside of this attribute value enumeration. So let's do something like, let's see, I have a fork, spoon. How about we do, let's go to bedroom here. And let's do a side table 3 feet maybe instead. So I have a side table 2 feet, but we're going to add a new one called side table 3 feet. So let me just copy that value and then change that to 3 feet. And then we'll do .toString. And then we'll do the same thing for the, let's see, we want to do the same thing for the P name as well. So actually P category here, sorry, I got that wrong. This is supposed to be bedroom. And then what we're going to do is just duplicate this down, and we'll do P name as the attribute name. And then here we'll do side table 3 feet. All right, that looks good. And then let's see what else. We also have to call the build function on this put builder, and that'll turn it into a put data structure, but that is actually wrapped by a result. So we have to do .unwrap to actually get the put data structure there from the result. All right, so let's go ahead and then pass in this put01 action into the transact write item builder and call .build on that as well so that we get the transact write item data structure. And then we can pass in this variable containing the transact write item data structure into transact items here. All right, so I think we are pretty good here. Let's just check to see what other things we might need to add to our put operation. So I'm going to reference the API documentation here. The condition expression here is totally optional, so we can actually go to the API reference for the put data structure right here. You can see that the item is required because we have to specify the item's schema attributes, which are p category and p name. The table name is also required because we have to tell DynamoDB which table we are adding the item to. The condition expression is not required. That's just an optional conditional statement that we can say, only put this item if this condition is true. We have expression attribute names and expression attribute values, which are basically methods for you to substitute values into your condition expression. And then we also have this optional, not required attribute down here called return values on condition check failure. And so we're not going to do that. So I think we're good to go here. Let's go ahead and just add in some error handling down here. So we'll say if the put result dot is error, then say print line error occurred while writing item to table. And so that way, this result type that we have right here, if it does result in an error instead of the successful transact write items output, it'll just print out an error message to let us know that something went wrong. All right, so also make sure you set your credentials, because of course you'll need that. Now we'll do a cargo run and see if it works okay. All right, so we didn't get any output here, which is a good sign. It probably means that the write operation was successful. I guess I could always do an else statement right here and say print line write was successful. And since we're doing a put operation, I should be able to just run it again, and I think it'll just overwrite the item if it already exists. Sure enough, it says write was successful. So we'll go over to our DynamoDB table right here. We currently have 8 items, and if we refresh, now you can see we have 9 items. And if we go down to the bedroom partition right here, you can see that we have side table 3 feet in addition to side table 2 feet, and this was created by Rust. But of course, you see it doesn't have is available or price attributes. So what we could do is just append those to the put operation that we're constructing right up here. So rather than just adding p category and p name, we could duplicate this down 2 more times and do is available. And that's a string value as well. And we'll set that to, let's see, yes. And then for the price here, our 2-foot side table is $24.65. So the 3-foot one we'll just say is maybe 29 something, 29.89. And then that needs to be a numeric data type. So we'll use the N attribute value instead of the S attribute value right here. All right, so let's go ahead and run this again. So we'll do cargo run. And hopefully that'll be successful. Sure enough, it says write was successful. So now if we refresh our table once again, we can now see that those additional attributes is available and price have been added to that item. So you don't have to use an update operation to add attributes. You can actually just do a put on an existing item, and that will add any new attributes that you've specified for that API call. So right now we have a write transaction that has a single put operation in it, but we could add up to 100 individual actions or operations that we want to perform inside of that single transaction, right? So let's say that we wanted to delete an item as well. So we can follow this same pattern here where we construct the action data structure, which will be a delete instead of a put. And then we could also specify the transact write item data structure here again, because this actually wraps put, delete, update, and condition checks. So let's say that we wanted to delete an item. And what I'll do is just use a different item as an example. So let's say that we wanted to delete the lamp right here. So what we'll do is say let del o1 action equal DDB types, and then there is a delete data structure. And then once again, the delete data structure has a builder function on it. So we'll just call that. And now that we have the delete builder data structure, we can always reference that in the API documentation here. Let's do delete builder. There it is. And now on the delete builder, we can specify things like the table name that we want to delete an item from. And we can also specify the partition key and the sort key of the specific item that we want to delete. So we reference the item in the same way, but rather than adding attributes with the item function here, we're actually calling the .key function to specify the attribute name and the attribute value that we want to look up. So let's do .key, and we'll say p category, and then the attribute value will be a string data type right here. String, not string set. And then we'll do a lamp. Actually, category is bedroom. And then we'll go ahead and just duplicate this. We need to do .toString here, otherwise it's going to complain. And then we'll duplicate that down and say p underscore name is going to be a string lamp. And then, of course, the table name. You don't have to specify them in any particular order. So as long as you do the partition key, the sort key, and the table name, it doesn't matter what order they go in, because ultimately it's just constructing this behind the scenes, adding it to the transact write item, and then calling the API here. So as long as you specify them, it doesn't matter what order. So for the table name, we'll say Trevor-products once again. And now we need to wrap this API call, or this action, into a transact write item. So let's do let del01 transact equal DDB types transact write item, just like up here. And then we'll do a builder. And then we're going to call, instead of calling the put function, we're going to call the delete function on the builder, and we're going to pass in del01 action. And of course, this needs to be converted from a builder into a delete action. So we also need to call .build on that. And then that's going to give us a result type. So just like before, we unwrap the result to get the underlying delete structure. All right, so now that we've added that, we also have to call build on the transact write item builder, just like we did before. And this one does not give us a result, so we don't have to unwrap that. It just gives us the transact write item. And then down here in our transaction, we can just call the transact items function again. But rather than passing in put01 transact, we'll do del01 transact. So now every time that we run this, it's going to add or update our side table 3 feet, but it's going to delete our bedroom lamp. So if we go ahead and do a cargo run operation here, we have a single transaction with 2 items. And as you can see, the write was successful. So if we come back over to our DynamoDB table here, we currently have 9 items, and we should be back down to 8 items. We still have the side table 3 feet because we wrote that, but you can see that the bedroom lamp no longer exists inside of our table here. So that's the put operation and the delete operation. But we can also do a set operation as well. So if we want to look up a particular item and make a change to a particular attribute, we can use the update operation. So let's try to assemble one of those as well. So I'm just going to continue to build on this, and we're going to add a third action. So we'll do let the update action. Let's do update 01, just so we can increment that number if we want to add more in the future. And then we'll say DDB types. And this time we're going to do an update operation. And then we're going to create a builder once again. We're going to specify our table name, just like before, Trevor-products. And then we're going to specify our keys. So which item do we want to update? Let's say that we want to update the price on an item. So P category is going to be attribute value S. And we're going to do the, let's say, kitchen items. So kitchen partition .toString. And then we're going to add our sort key, which is P name. And we're going to set that to about the microwave. Let's say that the microwave price goes up to $44.98. All right, so P name is going to be microwave. And then we need to specify the actual update operation that's going to occur. So to understand the data structure here, I'm just going to go back to the REST API documentation for transact write items. And let's take a look at the update operation here. So we don't need to worry about the condition expression right here, but what we need to do is specify our update expression right here. So the update expression is something that we can refer to in the documentation here. And basically we have these different keywords. We have the ability to remove an attribute. We can add an attribute if it doesn't exist, or we can delete here as well. So let's just see what the difference is. So with remove, we can delete an attribute. With delete, we actually are removing elements from a set. So if we have a string set, which is like a string array data type, we could delete an element from that string set that belongs to a particular attribute. But the remove keyword is different because it's actually deleting the entire attribute. So I'll probably talk about sets in a different video just because it's a little bit more of a complex data type, but it's kind of like having a string, but rather than just having a single string, we have multiple strings as part of an attribute. All right, so what we need to do is set our update expression here, and this is just a string. So we want to update the price. So what we're going to do is say set action is going to be a path equals the new value. So let's go ahead and say set price equal, and then I think that we can use the expression inputs for this. So yeah, expression attribute values. And then what we can do is create these placeholders so that we can substitute the new price. So I'll say set price equal to colon new price, new underscore price. And then what we can do is specify an expression attribute value for colon new underscore price and set it to the new attribute value that we want to apply. And so this is a number type, not a number set, but a number. And numbers, just due to the Rust API, we have to pass in a string and convert it to a number with attribute value. I think we said we were going to go up to 3498.toString. And so now this new price substitution will replace the value with 3498 in this update expression here. And if we wanted to do something else, let's say that we also wanted to maybe remove an attribute. So let's go back over to DynamoDB. We could say, maybe I want to remove the isAvailable attribute. So I want to actually update to 4498 because the price is going to go up. And then isAvailable, we could optionally remove that attribute. So let's see if we can do compound operations here. To be honest, I'm not entirely sure if we can. So let's see if it's going to allow us to do compound operations. It says an update expression consists of one or more clauses. We can include them in any order. Each action only appears once. So if we wanted to do multiple operations, it looks like we would probably, let's look for an example right here. So we've got update expression, that's just one set operation. We've got set price, that's doing a little bit of math here to actually subtract a value. For example, maybe reducing inventory. So let's go ahead and try doing a multiple clause here. I don't see any examples actually using multiple update expressions. So yeah, set equals value and then directly after that. So there's no separator here. So we can literally just specify another keyword and then specify the attribute that we want to remove. All right, so that's a pretty simple syntax here. So what we'll do is say set price equal to the new price, and then we want to remove the isAvailable attribute from the microwave as well. And it looks like the Rust analyzer is just messed up a little bit there. So let's reload our window. And then let's turn this update action builder into the underlying type. So we'll do .build on that. And that should give us a variable with the update data type. And then we need to construct another one of these transact write items here. Also, we need to call .unwrap on the update because we get a result type there. So we'll do .unwrap. And then we'll call this update 01 transact. And then instead of calling the delete function, we're going to call the update function and pass in the update 01 action. All right, so now we have 3 different actions that we're performing as part of one transaction. We have a put operation, we have a delete operation, which has already deleted our lamp, but that's fine. We'll just leave that in place right now. I don't think that'll fail the transaction, even though the item doesn't exist at the moment. And then the update action down here will update the microwave to set the new price to $44.98. And then it's going to remove the is available attribute. So just to show you really quick, if we refresh here from the live data, we can see that the microwave does have the is available attribute. It's currently set to no, and the price is $39.98. So I just want to show you there's no smoke and mirrors here. Those are the actual values in the DynamoDB table. So now we need to add the update transact here to our list of transaction actions. So let's go ahead and specify update 01 transact in there. So now we have 3 actions in our API call. So let's go down here and do a cargo run and see if this works okay. Now, I think the error here is probably because I reloaded the window. So let's go ahead and reset our credentials here once again. And we'll go back to Rust here, and in this new shell, we'll go ahead and do cargo run, and sure enough, the write was successful. So even though the item that's referenced by the delete operation already had been deleted from our previous attempt, it went ahead and succeeded anyway. The put operation, of course, is succeeding, and then the update operation here should have updated the microwave. So let's refresh here, check the microwave. Sure enough, the is available attribute here is gone, and the price has been updated to $44.98. Perfect. So that's how we can do a compound expression as part of an update expression that's unique to the update operation. We don't have that for the delete, and we don't have that for the put. But something else that we can do is the check condition. So we can actually check a certain condition in a DynamoDB table, as long as it's in the same account and region. It could be in a different table. It just has to be a table in the same account and region. But we could check that before we actually apply this transaction, right? So let's say that we only want to apply the transaction. Let's go ahead and actually add in the attribute is available to the microwave again. So I'll edit the microwave, add attribute, string, and say is available, set it to no, and save that. So now we've got that no in there, and then I'm going to go ahead and just click on the edit button here for the price attribute and bump that back down to, let's say, $5 so that we can reapply our transaction and actually see the effects of it. And now what we're going to do is add in a check condition. So basically our entire transaction is going to fail unless the check condition returns true. So let's say that we only want to apply the transaction if the fork exists in the table. So if the fork doesn't exist in our table for some reason, then we want to fail the transaction. But if the fork does exist in the table, then we can go ahead and apply the transaction. So we're not going to actually affect the fork at all, but we are going to look it up with a check condition. So what we're going to do this time is go into the DynamoDB crate for Rust here, go down to, let's search for check condition. Let's go to modules, and let me make sure I'm at the root here. Go down to modules types, and then we're going to search for check. So it's actually called a condition check, not a check condition. So I just got that backwards. So what we'll do is construct this. Then we can specify a condition expression here, and this will allow us to do a comparison on an item that we look up with the key here. And then that condition, if it returns true, will allow the transaction to succeed. So what we're going to do is say let check 01 action, just like the other ones. We're going to set that to DDB types, and then say condition check builder. And then we're going to go ahead and do .build.unwrap. And then on the builder, we're going to go ahead and specify our table name. We'll use the same table name, which is Trevor-products. Again, it could be a different table if you want to. Set our keys. I'm just going to go ahead and save some time by copying these from up here that already have the schema specified there. And we'll just change so kitchen is fine, but then we want to change this to fork. So we want to look up that item, and I need to bring that up above our actual API call to transact write items, because we're going to append this. And then once we do this lookup on this item, we need to specify what our condition expression is. Now the condition expression, very similar to something like the update expression right up here, is just any type that implements the into string trait. So if we hover over condition expression, you can see that it just needs to have into string. So it could just be a string value, basically, a hard-coded string. And then as far as the actual value that we pass into it, there is the filter expression. So let's search for filter expression right over here. And the filter expression syntax can be used in the condition check here. So let's do filter expressions. And then I want to look for the syntax for filter and condition expressions. So condition expression is what we're dealing with here, but this applies to both filters and conditions. So essentially, we have this syntax up here where we can say, a number could be between like 5 and 10 if we wanted to. We could check if a value is in a list of values. But what I'm going to do is just check to see if an attribute exists. And so this is basically just going to validate that the item itself actually exists. So what we're going to do is just check that the category exists by saying attribute exists. And then I'll put a placeholder here for adder01. And then to substitute that adder01, I'll use the expression attribute name, because we are referencing the name of an attribute, not the value of an attribute. And so then for the placeholder, I'll do pound adder01, and the value will be pound, or let's see, fork, I think. No, P category. All right, so let me explain what's happening here. We're looking up an item based on the category of kitchen and the name of fork. If that item is successfully retrieved, then it will check to see if the attribute P category exists on that item. And of course, if the item exists, P category has to exist on the item, because P category is the partition key, and every item must have its partition and sort key as defined on the table. Otherwise, you just can't write the item into the table. It has to match the key schema for the table. So all we're doing is basically just validating that the item exists by checking one of the two required key attributes on that item based on the table schema. So that's essentially what we're doing here. And then once again, we need to wrap this in a transact write item here. So let's pass this in, and then I'll do check O1 transact is going to be a transact write item. And instead of calling update here, we're going to do dot condition check, and we'll pass in check O1 action. And finally, we'll add this transact write item to our DynamoDB transaction. So let's do check O1 transact. So now we've got 4 actions. Again, we have a maximum of 100 items or actions that we can add to a transaction. And so right now we have 4 different actions. One is a put, one is a delete, one is an update, and one is a condition check. So if this condition check fails for some reason, then the entire transaction is going to fail. So let's actually make it fail first by changing the key that we're looking for to fork2. So fork22222 obviously doesn't exist in our table, right? Let's just refresh here. We don't have kitchen fork22222. We just have fork, right? So when we run this, the transaction should fail. So let's go ahead and compile and run our application. You can see it says error occurred, and I just want to make sure that that error is occurring because of the reason that we just outlined. So let's go ahead and print out the debug output of put result dot error. And then we'll go ahead and do a cargo run once again, and this will give us the specific error from the actual API call. So let's take a look at the error here, and it says the conditional request failed, right? So our check condition failed, therefore the entire transaction failed. So we could use this structure here to check to see if there was an error, and then we could actually drill into this error and check to see if it was this error message here, this cancellation reason. And then based on that, we could say, okay, well, one of the condition checks failed inside of your transaction here, right? But if we make the condition check succeed by referencing a valid item in the table, that'll return a truthy value. So if we do cargo run, we should see that our write operation has succeeded, right? So now if we come back here and refresh, the fork hasn't actually changed because we simply had a condition check that references and does a comparison on the item. We're not actually mutating any of the attributes on the fork. However, the microwave has been successfully mutated again as part of the transaction. That previously failed because the condition check failed, and that caused the entire transaction to fail. But now that we fixed the attribute name or attribute value for the product name of the fork, that condition request returned true. And so now the rest of the transaction actions were allowed to succeed. The price of our microwave went up as well. The delete and the put operations would have also succeeded, even though they had already taken effect from previous calls. So we have our side table and our bedroom lamp is gone here. So anyways, those are the 4 different actions that we have as part of the transact write items API call here. Again, it's condition check, put, update, delete actions, and each of those can be used for a specific purpose so that you can fail the entire transaction with a condition check. You can write new items with put. You can update existing items using an update expression, which is a unique syntax in DynamoDB, using an update action. And then finally, you can delete items using a delete action as well. So we didn't take a look at all of the different update expression capabilities here. Again, remember that we did test out the set and the remove here, but you can also add and delete items from a string set or number set or any of the kind of array types that are supported by DynamoDB. But I just wanted to keep things simple with scalar values rather than getting into arrays in DynamoDB attributes. In the future, I might put together a video that covers some of the more advanced data types in DynamoDB. And at that point, we might be able to drill into the update expression here. I think the update expression should also work if you're just doing a singular update. So if you do the update item to affect just one item in a specific table, the update operation or update expression should also be available inside of here. And sure enough, you can see it right down here. So update expressions apply to not just the transactions, but also to individual update item operations, and it should also apply to batch write item as well. In my earlier video, we talked about the difference between batches and transactions. Batches have a payload size of up to 16 megabytes instead of 4 megabytes, but batches can only have 25 actions, whereas transactions can have up to 100 actions. And batches, if part of the batch operation fails, it's not going to roll back the entire operation like a transaction does. So we have that atomicity that we talked about in the previous video with transactions, whereas batches do not have atomicity. But if we take a look for update expression in here, I thought that would appear in here, but we have delete request, put request, so we don't have an update operation in the batch API here. So apparently the update expression only works with transaction writes and individual update item APIs in DynamoDB. All right, so that's pretty much everything I wanted to go through in this video. I just wanted to make sure that we covered the 4 different types of actions in the transact write items API. And so hopefully after watching this video, you'll be able to implement your own DynamoDB write transactions and have atomic operations against your different tables. The only thing that we didn't really look at here is doing a write transaction across multiple tables, but all you have to do is just change the table name, and as long as you're referencing the correct key schema for that particular table, it should work perfectly fine. In the previous video where we talked about transact get items API calls, we did actually take a look at how to read items from different tables in the same account and region and in the same account, right? So anyways, I hope you enjoyed this video. Make sure you subscribe to our channel. Also leave a comment down below. Let us know what you thought of this video, and we'll see you in the next video. Until then, take care.